Alright everyone, welcome back. Today, as we continue with our mobile app, we'll be using Firebase as our backend. Specifically, we are going to be working with Cloud Firestore, which is Firebase's flexible and scalable NoSQL cloud database. You should think of Cloud Firestore as a way to store and sync data for your mobile and web applications. It's different from traditional SQL databases in the way how it organizes data. Instead of tables with rows and columns, Firestore uses a document-oriented model. And here are the key concepts you need to know. The first one are collections. These are like top-level containers for your data, and you should imagine them as folders that hold your documents. For example, you might have a users collection or product collections. And in the concept of our restaurant recommendation app, we are going to have a restaurants collection. The next one are documents. These are individual records within a collection. Each document is a set of key value pairs. The values can be strings, numbers, booleans, arrays, objects, and even other nested collections, though generally it's better to keep nesting shallow. Each document also has a unique ID. The next one are fields. These are the key value pairs within a document. For instance, a user document might have fields like name, email, and age. And last are our subcollections. Documents can also contain subcollections which are useful for organizing related data that is specific to a particular document. For example, a user's document might have a subcollection called orders. Now you might wonder why you should use Cloud Firestore. And the first reason is the real-time updates. Firestore has built-in support for real-time data synchronization. This means when data changes in the database, your app can automatically receive those updates without you having to manually refresh, and this is fantastic for building dynamic applications. Firestore is designed to scale automatically, to handle large amounts of data and high traffic without you needing to manage the infrastructure. And also the flexible data model. The NoSQL document model is very flexible and allows you to structure your data in a way that makes sense for your application without being constrained by a rigid schema. Firestore also provides a powerful querying capabilities to retrieve specific data based on various criteria. And the integration with Firebase. It integrates seamlessly with other Firebase services like authentication and storage, making it a complete backend solution. In our coding session today, you will see how we connect our Expo app to our Firebase project, how we read data from a Firestore collection, write new data to Firestore, and listen for real-time updates to our data. So get ready to see Cloud Firestore in action and understand how it can power the data layer of your React Native applications. And let's start by creating our Firebase project. As we dive deeper into building our restaurant recommendation app with React Native and Expo, we'll be heavily relying on Firebase for our backend needs. While the standard Firebase console is undeniably powerful, I want to quickly highlight a fantastic, recently introduced tool that could be a game changer for your development workflow, and this is Firebase Studio. Think of Firebase Studio as a more streamlined and visually intuitive interface for interacting with your Firebase data, especially Firestore. It offers a cleaner layout that often makes it easier to browse, edit, and manage your collections and documents. For those who appreciate a more desktop application feel, Firebase Studio is a breath of fresh air. Beyond its intuitive interface, Firebase Studio is powered by advanced AI. It's described as a platform that uses AI agents to streamline the entire development lifecycle, and this now prominently includes Gemini in Firebase. Imagine working quickly and efficiently with AI assistants that can interact directly with your codebase, taking actions on your behalf. This means you can complete a variety of tasks like coding, debugging, testing, refactoring, explaining, and documenting code with unparalleled ease. You can even use the built-in model or select your preferred one. The promise of getting working minutes by importing existing repositories or platforms like GitHub, or even letting you prototype new applications using natural language and visual tools becomes even more powerful with this AI integration. Plus, the ability to customize the environment with Nix offers a level of flexibility that can be incredibly beneficial for unique project needs. Google also recently introduced new Gemini Code Assist agents that are designed to help with everything from migration to AI testing, and you can sign up for the waiting list to get early access. While we'll primarily use the standard Firebase console during this session, to ensure everyone is on the same page, I strongly encourage you to explore Firebase Studio on your own. As we move forward and start working with our restaurant data in Firestore, keep Firebase Studio in mind as a potentially more user-friendly way to visualize and manage that information. Now supercharged with AI capabilities, it could truly transform how you interact with your Firebase projects. Now I'll guide you through the process of setting up a Firebase account and integrating it with a React Native app using Expo. The first thing we have to do is to make sure we actually have a Firebase app configured. If you already got something in place, you can of course skip this step. Otherwise, make sure you are signed up. It's free. You should go to firebase.google.com where you can read the Firebase documentation, the features it provides, and you can also add new project inside the Firebase console. The Firebase console shows you a list of all of your projects. I'll click Create a new project, and we'll provide a name for our project, and in this case will be local bytes. As you can see, it adds unique ID to the name of our project, and I will click Continue. Again, Continue, and at this point you can select whether to enable or disable Google Analytics for the project. I will disable it because this is a simple project, but for production projects, of course, it's good to enable Google Analytics, and I will create the project. On the left-hand side, you can see all the features that you can configure in your Firebase project. For this app, we'll only use the authentication and Firestore database. We'll use anonymous authentication for this app, and we should click on Authentication, Sign-in Methods, select Anonymous, click Enable, Save, and this is how the anonymous authentication is enabled. The next thing we have to do is to enable Firestore database. You should click on Firestore database and choose Create a database. We have to choose where our data will be stored, and you should choose the region that corresponds with your location. In my case, since I am located in Europe, I will select Europe. Firebase is providing also option to start in production mode or in test mode. And since this is for educational purposes, I will select test mode and create the database. Once we have created the database, we need to find the web configuration for the app, we should go to Project Overview. Since this is Expo Manage React Native app, we need the web configuration. This is the icon which you have to select, and you should register your app. I will provide again the name for Vocal Bytes. And here you have option to add Firebase hosting for this app. We don't need Firebase hosting. We will just register the app. It takes some time. You can copy this information, or you can always find the config again by selecting the project, settings, and here you can find the reference to your config. The next step is to install the Firebase package, and there are two ways. As you can see from the Expo documentation, you can use the Firebase JavaScript SDK or React Native Firebase SDK. Using the Firebase JavaScript SDK is the way what we are going to use, because this is Expo managed React Native project, and the command we need to install is this. I'll open a new terminal and just paste the command. It takes some time, and now the Firebase package is installed in our app. Now we need to bring in our Firebase configuration, so let's create a new Firebase config file and fill it with the information which was generated during the creation of the project. We should go to the Firebase console and copy the information. In addition to the configuration information, I've also added the Get Firestore and Get Auth in order to create instance for our database and authentication, which we'll need in order to retrieve the data from Firestore. This will initialize a connection to Firebase using the modular way of the Firebase SDK, and we also export some tokens to access them later. To finish the Firebase integration, we need to create a custom metro config as well. So we should run the following command in our terminal: npx expo customize metro.config.js. And let's see, we have created the metro config file. This file is a very common and often generated configuration file for Expo managed React Native projects. It sets up the metro bundler, which is responsible for compiling and optimizing your JavaScript code and assets for your mobile application. You can see the images currently are not visible. Let me remind you what we did last time. We created our utils.ts file with the dummy data for our restaurants, and we were getting the images locally from our assets folder. But there is one important thing for Firestore, and this is that it can only store serializable data like strings, number, etc. And when you upload this data, Firestore stores the images as object or a number, which is not usable for displaying images from Firestore. That's why I uploaded the images to image server, and this is post image, in order to be able to fetch them and updated the source accordingly, as you can see. Of course, you can also use Firebase for uploading the images, but you have to upgrade your billing account, and I just wanted to show you free alternative, and this is post image. I will go back to Firestore to make sure that our database is empty. And we have a few goals for today. First, we are going to implement functionality to upload the mock data to our database. And I'll also add functionality to retrieve the data from the database. And lastly, we will add functionality to delete data from the database. And finally, we will also create our search functionality. So the first thing we have to do is to create our add restaurants function, and we will do that in our home screen. I will create the function and we'll call it add restaurants. It will be async function. And in our try block, I will use a condition for getting our restaurant from the mock data. And actually here I will add the restaurants as mock restaurants. And this is what I'm going to do in our try block. For const, again this typo, for const restaurant of mock restaurants, what we are going to do, we are going to await add doc. Add doc is function from Firestore, which allows us to add documents to our collection. And here in our add doc, we will pass the collection. We already created our database integration here in our Firebase config file. So I will call the DB, and of course I have to import DB from Firebase config, and provide name for our collection, and in this case it will be restaurants. And finally we'll use the restaurant. And I also have to import the collection from Firestore. And in order to be sure that everything is working as expected, I will add also a console log message, which will say that all restaurants are added successfully. And additionally, what we have to do here in our catch block, I think I have a typo, but I will fix it later on. So try, okay. I'll just add here additional curly brace, and here I will catch the error. And in case of error, we'll just console log error adding restaurants and the type of the error. We can temporarily trigger the upload of mock data using the use effect, and this is what I'm going to do right now. I'll just import use effect from React. This way, the upload will run once when the component mounts, and be careful, it will run every time the app reloads. So I will comment it out after the first run to avoid duplicates. And now just here, and now here I will just use the use effect in order to trigger the upload of our collection. And here we just have to invoke the add restaurants function. Additionally, I will create also a state variable for restaurants, which I will use to pass it to our flat list here in order to replace the data from the mock data with the real data from Firebase. Set restaurants, and here I have to import useState, and here instead of mock restaurant I will pass empty array, and this state variable will be of type, let me remind you, last time we created the restaurant card props interface, and this will be the type for our state variable. Let me just copy it in order to avoid some errors. And of course import. I think I have import from restaurant card, and I will just add the restaurant card props to the import. Okay, the error says that there is no exported method, which means that here I have to add the export interface in order to be able to use this interface in another component, and this actually has to be array of restaurant card props. And let's see, do we have all restaurants added successfully? Okay, let's go to our Firestore database to make sure that the data is uploaded. And voila, here we have our restaurant collection and the different items from the mock data, which is now uploaded to our database, which is great. We are done with the first step, which is to add data to our Firestore database and respectively to Firebase. I commented out this use effect in order to avoid multiple uploads, and let's see. Oh, the data is not visualized because we have to create our function for getting the data from the database. This use effect listens in real time to changes in our restaurants collection from Firestore database and updates our app state, the restaurants, when the data changes. Let me explain how it works. OnSnapshot is the function from Firestore. It sets up a real-time listener on the restaurants collection in Firestore. Every time the data changes, and you can imagine add, update or delete, the callback runs. It maps over all documents in the snapshot, creating an array of restaurant objects with their Firestore ID and all other fields. If there is an error, like fetching the data, it should be logged here. And finally, we have a cleanup. When the component unmounts, it unsubscribes from the Firestore listener to prevent memory leaks. Now let's see if the data is visualized. Okay, we have our restaurant cards visualized properly, but what is missing are the images. And I think I know what's the issue here. In our restaurant card, we are passing the image as prop, but instead it should be passed here. We should pass our URL because we changed the way how we get our images. They are not stored locally in our assets folder anymore. We have to take them from our database, and the correct way to do this is to pass the URI. And here we have to delete the second. And let's hope. Yeah, here it is. The images are now loaded, and our restaurant recommendation app actually is now connected with Firestore. First we added the data, now we retrieve the data from Firestore, and the last thing which we have to do is to create the functionality to delete the data, and of course finally to create the search. Let's continue with our delete functionality. The delete function will be executed in useEffect, and let's start by getting all documents from the restaurant collection in Firestore. For the adding the restaurant, we were using the add_doc function from Firestore, and for getting, we have to use the getDoc. I import the function from Firestore, and here it is, getDocs, and we'll start creating the logic for the function. So I will call the function delete all restaurant. Restaurants will be async function, and in our try block we will first create an array from all documents in our restaurants collection. The first is to create the query snapshot, which will be the array of all the documents from our collection, and here we will await the getDocs function in order to get all the information from our collection in our database, and our collection in our database is restaurants. The second thing we have to do is to create a promise for each document to delete it, and this is how we can do it. Const batch deletes equals query snapshot dot, no, it should be this query snapshot dot docs dot map. Here we are going to map our docs, and the final thing which we have to do is, once the docs are mapped, we have to delete doc. This is again function from Firestore, and we are passing again our reference to our database, our collection, restaurant, and docsnap ID. And here, we have to import the doc again. The next thing we have to do is to await for all delete operations to complete. This will happen with promise.all, and we are passing batch deletes, and it will be good to have some visual indication that all data has been deleted. So I will also add console log message in a way of success that all restaurants have been deleted successfully. And we also have to add our catch case where we are going to catch the error, and in case of error we are going to console log the error. And as I said, we will execute this delete function in useEffect, similar to add restaurant, and I will just add this useEffect. This is for temporary deleting the data from the database, because I want to show you also this functionality. Okay, there is nothing rendered in our app. Let's go back to our database, and there are no documents, which is great. I'll go back. We'll comment out this delete functionality, and we'll uncomment the @restaurant function in order the data to be uploaded to our database, and we will continue with our next step. Here it is. Now we have our data back, and the final thing which left is first to comment out this useEffect, and finally to create our search functionality. The first thing which we have to do for our search component is to make it stateless. This means that instead of passing search query and set search query as state variables to our component, the state for the component will be managed from its parent, which will make it reusable and easy to control from outside. So I'm going to comment out this state variable and instead add interface for set search bar props, and I will add the search query as a string, and set search query will be function which will be passing a string. And of course I will also have to pass the props here to the component, and this is the way how we can do it, and add search query and set search query here. Okay, I will also delete this line here because I don't need it anymore, and we are ready to create the filtering functionality for our search. First thing which we have to do in order to make our search component stateless is to move the state which we removed from the search component. We have to move these state variables to home, and this is what I'm going to do right now. I will add the search query and set search query here as a state variables, and you can see that the search bar is complaining for missing props, and I will just pass the search query, which won't be empty string but will be the search query from the state, and also the same for set search query. Okay, and now we are ready to manage the state. What we have to do is to create a filtering function which will filter the list of restaurants to only include those whose name or categories contain the current search query. So I will start with creating the function which will be filtered restaurants. It will filter through all of the restaurants, and what I'm going to do here is to add a query which will be case insensitive, and in order to make it case insensitive is to add to lowercase both the restaurant's name or categories will be converted to lowercase, and only restaurants matching the search query in their name or categories will be included in filtered results. So I have to return here the restaurant name, which will have to include the query, and categories to lowercase, and I have to also fix some errors. I have a missing curly brace as far as I can see, and what else I also have to add. I fixed the errors, and what we have to do here is, instead of passing restaurants to our flat list, we have to pass the filtered restaurants. And let's see our search bar. Let's test. Okay, I will try with cakes. Okay, we have two results for cakes. What else? Let's salad. Okay, we don't have. Okay, we need to add also a placeholder when we don't have a matching result, but it looks like it's working. Okay, great. Now what left is to add the placeholder in case of no matching search terms. In order to add this text placeholder for the cases when no restaurants are matching our search query, what we have to do is to add a condition, and this condition should be that if the filtered restaurants length equals 0, it will render a text component, and I have to add this import from React Native. If there are no matching search terms, I mean there are no restaurant, what we are going to display is let's say this will be the placeholder, no restaurants found matching your search. Otherwise, what we are going to do is we are going to render the flat list. Alright, I'll just delete these empty lines, and yeah, I think this looks good so far. Let's see if it's working. I will just no restaurants found matching your search, which is great. Well, I think that with this placeholder which we added for our search bar, we are done with our project, and I hope that you enjoyed this simple tutorial. We successfully built a React Native app that connects to Firebase, displays a dynamic list of restaurants, supports real-time updates, and includes a search feature with user-friendly feedback. And you also learn how to add and delete data in Firestore and how to handle images using remote URLs. I think that this wraps up this session. If you have more questions or want to add new features, feel free to ask, and don't forget to follow us on all of our social media channels. Thank you, until the next time.